So we're to simplify here, and we're going to take this very convenient idea that we have a base of 2 and we're raising it to an exponent. You say, but we're raising it to a log. Well, you know from me saying this so many times that a logarithm is an exponent, and so we're using a logarithm as an exponent, and lucky us, it's an exponent, and it's not just any exponent, but it's giving us an exponent for 2, which is what we're raising our 2 to. So if we're raising a 2 to the exponent and we're looking for an exponent of 2, that's perfect, okay? What we're saying here for this first one is I need an exponent such that if I raise this 2 to it, I will get 3. Well, I don't know what it is, but if I raise 2 to it, and here's my big 2 that I'm raising to this exponent, then I'm supposed to get 3. Okay, I must get 3. There we go. That's all I have to do. Then I say minus here. And here we go. We got 3 down here. And we're raising 3 to something. And lucky for us, look at that. The base is 3. Let me fix something first. If there's a 2 out in front of the logarithm, I should really put that back in here. So let me rewrite this. I'm going to say 3 to the log base 3 of 2 to the second power is 4. Okay? So I'm going to say I'm raising my base, which is this 3 right here. I'm raising my base to some exponent such that I get 4. This is my desired result here, 4. So there's some exponent, and I'm using it as an exponent for the very same base. Here's my base, and it's the same base as 3. So if I raise this 3 to this, whatever this exponent is, I don't know what I raised 3 to get 4. It's going to be more than 1, because 3 to the 1 is 3. So it's going to be 1 point something to get to 4. If I say 3 to the second, I go all the way up to 9, so it won't be that high. It'll be between 1 and 2. I don't know what it is. And I really don't care, because it says that if I raise, this logarithm here is an exponent. And I'm saying that if I raise 3 to it, I get 4. And I'm raising 3 to whatever this is, so I get 4. So I say 3 take away 4. So same thing happens over here, except that we better simplify this first. And our rules of logarithms say that when I add exponents with the same base, 5 here in both places, I'm allowed to combine that. So I'm going to say 5 to the log, just 1 this time, base 5, of 4 times 6, that's 24. Okay? When I add my exponents, I'm supposed to multiply my arguments here, 4 times 6. So I do that. And again, I say the same exact thing I've been saying, and that is, there's some exponent for 5, such that if I raise 5 to it, I get 24. And look, I'm raising this 5 to that exponent, so I should get 24. Here's my plus coming down, and I get 24 from that. Okay, last situation here. I say, there's a 4 out here, so I'm going to raise my desired result to the 4. That's going to interfere here. I'm going to raise this to the 4th, so I now have minus the log of, and this is the only time I get to multiply my exponents, so I'm going to say the log, and you know that if I don't write the base, I mean 10, so let me go ahead and write 10 anyway, because I know that's 10 because I didn't write it. I have 10 to the 20th. Maybe that's too much writing in there. You know it's base 10. You're supposed to know it's base 10, so I won't write it. It looks like it's cluttering things up. So I have 10 to the 20th. Wow. Okay. So here's what I'm saying. There is some exponent. And I'm saying that well, I don't know what the exponent is, but I think I can figure it out, right? There's some exponent for 10, such that, let's say it's x. There's some exponent so that if I say 10 to the x, I get this desired result. Well, I have 10 to the 20, so x must be 20, right? Here's my base, and I'm saying my desired result is 10 to the something, and I'm saying I'm going to raise my base to something to get this. It must be that I've raised, since this is the same number, it must be 20. So I'm going to say minus, because there's a minus sign out here, and then 20. Okay. And we can verify all these things with our calculator, especially if it's base 10. I guess this last one would be pretty easy to verify if we wanted to. We could say log, and the calculator assumes 10, and then we could type in 10 to the power of 20, and it should pop out 20, because it'd say, do you really need me for this? Or you're asking me what I should raise 10 to if I want 10 to the 20. Sort of telling me what you want and the answer at the same time. Okay, so let's go ahead and just put these together now. 3 take away 4 is -1, plus 24 minus 20. -1 and 24 is 23. Take away 20. We're going from left to right. And we get 3. Our answer is a big fat 3.